Alright, in this video I'm going to show you few steps of using GCC. Okay, it probably very rudimentary, but I'm thinking of people who wanted to start with GCC uh, on the command line. So this video is all about showing few flags and the way uh, GCC should be used on the command line. Okay, so if you find it is useful, adapt it, so it will only benefit you. Okay, so without further ado, let me spawn up a terminal and let me move it to a designated workspace. First of all, let me zoom in so people can see. The first thing first, let me create a directory. mkd is a small function I have in my bash RC. It basically create the designated directory and get into it at once. If I do GCC demo, see, I'm inside that directory. So what it contains, declare f mkd. So this is the function I have in my bash RC. So it basically create the directory and enter into it at once instead of getting into one at one go. Okay, so first of all, let us write this absolute ordinary C program just to create the base so we can use GCC. Okay, so GCC demo .c. Okay, so, and if I write, okay, stdio.h and then int main, okay, and then one line statement printf, okay, this is GCC Flags demo, and padded with a new line, put a semicolon, return 0. I think that's good enough program to show all the stuff I wanted to show. It's just basically one line program, right? Simple function. Okay, so let me do it. So first of all, so if you want to compile the C program with GCC, so we write GCC and then the file name. If we do and press enter, now if I look into it, there is a.out file. Okay, so now that become executable. If I run this, it will say what is there in the program. Okay, so I'm deleting this. Say you want to name your executable binary as per, you write GCC demo -o for the output flag. That means after compilation, the executable create, which can be given a name with the -o option. This is what I do here. I just space -o, then the name I have given, then I call up the C program. If I do, now you can see there is a binary called GCC demo. Okay, again I am removing this for different reason. Okay, now here, say for instance, if I want, because while compiling, this is a simple program and complex program compile in various other, but behind the scene there are a lot of things going on. Okay, so to show you what is going on, because once you run, as you saw, there is no output whatsoever on the terminal, right? But it was doing so many things behind the scene. To show all this stuff, all you have to do, -v, okay, and then if you do GCC demo.c, you see it shows what it did behind the scene. Okay, so many output. Okay, so this is very handy. So you can see while running with a -v flag, you can see I'm doing it because the target program is small. If the target C file is huge, this output might overwhelm you, which I don't suggest you should run with a -v option. Okay, I'm running it for the sake of demonstration. That if you wanted to know what GCC is doing behind the scene, you could see those by passing -v option. Okay, all right. Now again, if I delete that stuff, okay, so now if I wanted to see that what is the assembly it generates, then I have to do GCC -s. This is the S for to generate the assembly. Okay, GCC demo. Now if I see there is a .s file, GCC demo.s. If I do GCC demo.s, see, this is the assembly the compiler generated with the -S flag. Okay, you can generate the assembly of any C program like this with pass the -S. Okay, all right. Now say if I wanted to see what is going on while generating the assembly, right? Again, -S, -O. Instead of giving it a name, I press hyphen, which means the standard output. That means in terminal. Okay, now if I do, okay, and if I pass -F, there should not be any space between -F and the verbose ASM, because I want to see how the assembly get generated out of C program on the terminal itself. That is why I give -O to a hyphen. That means it should be outputted on stdout, that is on terminal where we are. Okay, and verbose.asm means it will show you how verbosely the assembly is generated out of a C program. Okay, if I press enter, see, it will show you all the stuff. Okay, it collected the compiler and all this stuff, right? It is very, very useful for debugging purpose. Okay, so if you see the internals, how the registers have been manipulated, so it will help you to debug the program. Okay, you know what are the options passed to the compiler and what would be the compiler version and all this stuff. Okay, so it is very helpful for debugging. Okay, now if I do simply GCC demo.c, it will, okay, so let me do one more thing. Okay, if I do GCC-O GCC demo, okay, and then I call up the C function, if I do, it will create a binary, compiled binary called GCC demo, right? Say the program, now it is compiled fine. If the didn't, well, I mean, if the compilation haven't done properly, okay, so to debug that, the compiled binary should have the debug information in it. Okay, now generally what we'll do, we run the gdb, okay, to inspect the executable to find out where it is creating trouble, right? That is the normal process of getting into a debugging with a malfunction program. Okay, now if I run gdb with that executed compiled executable binary, okay, the yellow one, if I write C, if I do C also, it doesn't have any symbol, okay, so it doesn't have any symbol which could show you any debugging information. Okay, generally when you have a debugging symbol in the program, that the top pen, I'm running gdb with TUI mode, that's why these things are coming. Okay, so the source code will be appeared on the, see, there is no source available, it is because while compiling we didn't instruct the compiler to put the debugging information inside the compiled binary. Okay, so if we quit out here, and if we do, okay, so if we do gcc-c, then if I compile this C file, now again I just forgot to mention the output, so it by default create a.out as a, let me a.out, let me do it again. Okay, gcc-g to insert a debugging symbol inside the compiled binary. Okay, -g is the flag. So if I do o gcc demo, then I call up the C file. Now if I do, now if I run the gdb with gcc demo, because I run with a -g option, -g option will infuse the debugging information in the compiled binary. If I press enter and if I press C to continue, see, now the source is available, right? Now if I do just arbitrary rudimentary things I'm showing it here, 3, and then if I run it again, okay, so now it will play properly because it has got debugging symbol in it, so the gdb can play properly with this source code. I'm just giving you a absolutely a minimal information about how to get the debugging symbol in. Okay, so this is how you can run against the compiled binary in gdb. Okay, I don't know how fruitful it is, but if you have if you want to inspect the compiled binary, you have to have some mechanism to instruct the compiler to put enough debugging information inside the compiled binary so you can inspect, probably fix, probably enhance, okay, to run the by running the debugger. Okay, so without giving a -g option to GCC, your executable will not have the debugging information to parse by the debugger. As simple as that. Okay, now while compiling, there are several ways, several steps it go through to create the executable, right? Various files are it's basically, compiler is basically stepping through different file and ultimately create an executable. Okay, so again I'm removing the already created executable. Now if I do GCC -o GCC demo for the executable name, then if I call up the C file, then if I pass the GCC flag save temps, okay, --save -temps, if you pass that particular flag or option with it, it will show you all the files it passed through. Okay, if I press enter, now if I see there are one GCC demo.I file, GCC demo.o file, GCC demo.s file. This is an assembly file. This is the assembly file which I have shown you before in this video. This is an object file with the O option. This is an intermediate file with the I option. Okay, and this is the source file as I passed through, right? So if I look into this GCC demo.I, see, this is the intermediate file, right? It has gone through all this, it has take the steps to go through all these header files. Okay, so you can see by passing the save temp option to GCC flag, okay, so it will produce 3 different files. One is .y, one is .o, and one is assembly file, right? So for instance, say if you want to generate say if I delete GCC_demo.o, that's the object file, you can generate the object file by passing the C option to GCC. If you call up the C program, okay, and if you do, now you can get the O option because it creates an object file. Okay, you see on the process I deleted the previous object file. Now again run it GCC-C with the GCC file as an argument, so it will create the object file. Okay, so in a various step there are plenty of options with GCC, and the more complex the project is, the more complex the file C file is, they have so many flags, and if you know what are the flag to, so you can precisely chop out the part from what the compiler provide. Okay, so if you do man GCC, it's very intimidating in a sense. If you are not a compiler person, like normal person, this page will intimidate you. There is no fuss about it because it has got so many options. A compiler supposed to have so many options. Okay, so you can see there are so many options. Okay, and each has got a different meaning to it and different functionality to it. A compiler is the best. It's supposed to be very detailed and very extensive, and this is no exception. So if you are a normal person and not inclined to know the internals of the compiler, this page will intimidate you. But if you have an inclination towards system software or compilation related stuff, if you look into this man page, you will come to know a lot of stuff, okay, and which will be invaluable in the future. So if you are that kind of person, you can spend time in this manual page. Generally normal people whenever we want to use some specific flag with GCC, we hopped into this page, find out the specific option or look through the specific stuff, okay, and then we applied that from the command line. Okay, likewise, it's a huge page, but it is invaluable if you have an inclination to know what the compiler is supposed to do and should do. So it will be very entertaining for you then. Okay, the last thing I want to show you, that yeah, the compiler might have so many options, right? You can pass GCC flag from a file, very convenient. Say your compilation required so many flags, is very difficult to remember all this stuff. For that, just create a file. It's not supposed to be named flags. I'm writing it for our convenience, for the demonstration purpose. It could be anything, whatever you like. Okay, if you write this, and in that file if you write, say, wall happen error, okay, okay, all the or the function I have, okay, so you can write the GCC compiler flag in a file, okay, and now while compiling, you can call up the file which is having all the GCC flag, right, like at then the file name. Okay, so if I run, it might produce error, but the fundamental stuff is that you can put GCC flag inside a file and call up that file with at symbol prepended with the file to apply all those flags to the compilation. Okay, I believe I'm clear enough. So if I run this, so because I made a mistake in a spelling mistake, so that's why it is complaining. Okay, so this is way you can use so many GCC flag at once to put stuff in a file. Okay, put stuff in a file. So you can do that. Okay, so these are the little thing. Let me try once. I don't know whether it will. See, it takes all the flag. It doesn't spit out any error. That means it took all the flag and does the things. Okay, so this is how, these are the very rudimentary stuff I have shown to you to pass the -o for the output, okay, to pass -g to insert a debugging symbol in the compiled binary, okay, -o and then the dash to provide the stuff on the terminal itself, on the std out, okay, and then -f verbose -asm, that means it will show you how the assembly is generated out of the C file. You can generate a assembly file by GCC -S and then the C file. If you watch the steps what I have done one by one without skimming, you can see what I have shown you few of them. There are plenty of stuff that a compiler can provide, so I don't want to clobber your head with a lot of stuff. Okay, so whatever I have shown to you, it should be good enough to give you some kind of fillip that if you are really interested, you can peek through and start exploring. Okay, I hope this will be useful for some people.